Students, so today we are going to start another important theorem of similarities of triangle. Okay, so I hope that during last week whatever I have done, we have practiced well, we have revised. Now today, after a gap of one day, we are starting the next. So please be up to date. Don't keep anything pending, because if you keep anything pending, it will become a problem for you. Okay, so please be regular. Okay, so whatever I have done in my last, please practice time and again. And now today another very important theorem of similarities property, under the similarities property, and with this property also, in this, by using this theorem also, we can solve many questions. So theorem as well as application of the theorem is also very important in the perspective of the board exam. Okay, so please be careful and practice and try to grasp the concept of this theorem. Okay, the concept is most important, remember. And in geometry, I told last time also that diagram, if you can draw the diagram without looking, by reading the question, then that is half of the question is done. Okay. So today's question is that two similar triangles. Two similar triangles. If two triangles are similar, then the ratio of the areas of the two triangles will be equal to the ratio of the square of their altitude, their medians, their centroid and all. Basically here we will do the altitude. The ratio of the areas of the two similar triangles is equal to ratio of their corresponding side, square of the ratio of their corresponding side. That is the theorem number 6. And by using this theorem, we can do a lot of questions, many questions, and also we can do some more other geometrical apart from numerical calculation, we can do the geometrical proof as well. So let's see, start with today's class with the theorem number 6.6. Theorem number 6.6. Okay. So once again, similar properties. So please revise once that similar triangles. There are three conditions. So first is if two triangles are similar, then their ratio of the corresponding sides will be in proportion. Next is that the corresponding angles of the two similar triangles will be equal. And third condition is that ratio of the two corresponding sides proportional to the ratio of the another two corresponding sides of two triangle, and an angle included between them, because all these property will be utilized here. So please be careful. Okay, so first of all, let us draw two triangle. Okay, draw a triangle. Remember here, any triangle, here is not any particularized triangle. Any triangle you have to draw. Any triangle, triangle A, B, C, P, Q, R. Here triangle AD, here PM. Now what is that? They have given, according to the question, AD and PM are perpendicular. AD, PM are perpendicular. Now first of all is introduction. So what is the introduction? That let ABC and PQR, let ABC and PQR be two similar triangles. Let ABC and PQR be two similar triangles. Okay, let ABC and PQR be two similar triangles. So if these two triangles are similar, then what we can write? Triangle ABC similar to triangle PQR then what we can write, AB by PQ equal to BC by QR equal to CA by RP. Okay, this is the first, and then second is that angle A equal to angle P, angle B equal to angle Q, angle R, angle C equal to angle R. Well, now here you have to write from A and P, from A and P, AD and PM are drawn perpendicular on BC and QR. Once again, from A and P, AD and PM are drawn perpendicular on BC and QR respectively. Clear? Perpendicular, you can give this symbol because this symbol stands for 90 degree. This symbol stands for 90 degree. Okay? Clear? So here, why? So this much is the introduction gone, and to prove ER within bracket triangle ABC equal divided by ER within bracket triangle PQR equal to AD square by PM square. And similarly, if you can draw another altitude from B and Q, C and R, then those sides, those altitude will be also a square of the ratio of the square of those medians will be also equal to the area of the two similar triangles, ratio of the areas of the two similar triangles. Now, one question you may think that as we have drawn, this is according to the question, okay, that AD and PM, because altitude, they ask that a ratio of the areas of the two similar triangles equal to ratio of the square of their altitudes. Now, apart from that, you see the perspective of this theorem of what is the importance of this altitude. You see, this altitude importance is that, you see, we have already angle B equal to angle Q already according to the condition given condition, and then you see angle D's equal to angle D's, that is 90 degrees. That means ABD and triangle PQM once again similar. And from these we will get these two sides, AD and PM. Okay, so please keep in mind, in sometimes they will ask you to prove this one. Only they will ask you to prove this one. The triangle ABC, also prove that in triangle ABC and triangle PQR, this is equal to this. That altitudes. Okay, so that means you have to know that if you draw this one, what are the consequences or what are the steps you are going to do. Okay, so now let's see, start with this. Now already I have written AB by PQ equal to BC by QR equal to CA by RP. This one you can write as condition number 1. This is condition number 1 and this is condition number 2 we can write. Okay. Now main proof. There will be no construction because whatever we need already it is there according to the given question. So there is no extra construction. Okay. Proof. Say from triangle A, B, D and triangle P, Q, M, we get what we get is first of all already I explained angle B equal to angle Q. Why? By see angle B equal to angle Q. Next, angle ADB equal to angle PMQ equal to 90 degree, because that is also given, because AD and PM are altitude. Okay, therefore triangle ABD similar to triangle PQM. Why? By A. Other day also I told you that if you are writing two angle, you have to write two angle, because third angle automatically it will come. If two angles are equal in a triangle, in two corresponding triangle, then automatically third angle will be also equal by angle sum property of the triangle. Okay, so this part gone. Now from here, what will you get? That is the most important, because from here, if you are not able to write that appropriate thing, then it will be a problem. Okay, so then here you see, therefore AD by PM equal to AB by PQ. This is equation number 3. This is equation number 3. Okay, by similarities property. Now the important part, that is area of the triangle. Now you write area of triangle ABC by area of triangle PQR. Now what is the area of the triangle? Half into base into altitude. Half into base into altitude. That means half into base is BC, into altitude AD. Half into base is QR, into altitude PM. Okay, half into base into altitude. Okay, so write half into BC into AD divided by half into QR into PM. Half into BC into AD is the area of the first triangle, then half into BC QR into PM is the second triangle. Okay. Now let's see BC by QR. Okay, BC by QR. Now remember one thing, this part you no need to write once again, for as I have to rub, that's why I'll write down here once again, so that I can use it and I can show it again for the explanation purpose. Okay, AB by PQ equal to BC by QR equal to CA by RP. This one was equation number 1. Okay, this part I will draw. And angle, no need. Angle already we have utilized. Okay, angle we have already utilized. Now you see half of gone. Then what happened? Implies AR triangle ABC by AR triangle PQR equal to BC by QR into AD by PM. Yes or not? BC by QR. BC by QR is nothing but AB by PQ. AB by PQ into AD by PM. Yes or not? Now AB by PQ is nothing but AD by PM. AD by PM. So what is that? AD by PM into AD by PM. Using 3. And this one you can write down by using 1. Okay, using 1, then you're using 1 and 3. Better you write 1 and 3. Okay. Then you see, ultimately what we will get, whatever we are supposed to prove, then we are getting that. You see, ultimately equal to AD square by PM square. Similarly, if it will be suppose from BC, from B or C, Q or R, then also same way you can prove. Okay, just I'll wrap up once again as a whole. See, first of all, let ABC and PQR be two similar triangles. Then AB by PQ equal to BC by QR equal to CA by RP, and angle A equal to angle P, angle B equal to angle Q, angle C equal to angle R. Then from A and P, AD and PM, from A and P, AD and PM are drawn perpendicular on BC and QR to prove AR within bracket triangle ABC equal to divided by AR within bracket triangle PQR equal to AD square by PM square. Okay. Then first of all we have done that these two triangles similar, triangle ABD and triangle PQM, and then it is similar by angle B, angle Q, angle this and angle this. Therefore AB by PQ equal to AD by PM implies BC by QR equal to AD by PM. You can write down that one also. If you are not writing, then remember you have to write here using 1 and 2, 3, and then AD square by PM square. This is the end of this theorem. Okay. Now we will go to the exercise 6.4. 6.4. Please go through the question. 6.3. First question is that it is already given the area of the two similar triangle given, and then the altitude is also there, and you have to find out that missing. Now what is the missing here? That only you have to see. What is the missing here? Exercise 6.4. What is the missing here? Missing is that it is BC is missing. What is given? Triangle, question number 1. Triangle ABC similar to triangle DEF. Then what is there? Then you see it is given that ER within bracket triangle ABC by ER within bracket triangle DEF equal to BC square equal to EF, area of the. So see here what is given, find BC. So already you got that if the side is also ratio of their side is also that means square of the ratio of their sides. Okay, so BC square by DE square, sorry, BC by EF, BC by EF square. Okay, BC by EF square. Then you see here area is given, both the triangle area is given. What is that area? Area is 64 and 121. So 64 and 121 equal to 15.4 and BC and 15.4 whole square. Then what is that? BC by 15.4 equal to root of 164 by 121 equal to 8 by 11. Now you just cross multiply. Then what will happen? 8 into 15.4 by 11. 15.4, it is 1.4. 1.4 into 100 and into 8 equal to how much? 1.8. Sorry, 1.2, because 14 8s are 112. So one decimal is that decimal. Now here most of you may think that I have done that ratio of the areas of the two similar triangle equal to ratio of the square of their altitude. Actually, in their theorem it was given side, but I have done altitude. That means I want to show that if it can be the side, it can be the altitude, it can be the median, anyone. Okay, so I have done there AD square by PM square, and that is nothing but, you can see, AB by PQ. Okay, that means this one also can be, or this one also can be. So that's the reason intentionally I have done that one, so that you do by yourself this one. Okay, you do by yourself this one. Same procedure, nothing difference. I replaced AB by PQ by AD by PM. That was the difference. And you, according to this theorem, just you replace AD by PM by AB by PQ, then AB square by PQ square. And that's the application used here. That is the application used here. Okay? So that is the application used here. So please don't be confused. That side has done that instead of AB by PQ square equal to AD square by PM square. Same. That one is replacement only. That means I want to tell you that if it is the ratio of the square of their side, then it can be ratio of the square of their altitude. It can be ratio of the square of their medians as well. Okay? Then question number next. So next question I'll do in my next class. Okay? So still that, because this is very, very important, because you see here I have done with altitude. You have to do with the side, and then you try to do with the medians as well. That means I have done one, you have to do another two, and also if possible question number 2 exercise 6.4. Thank you.